In this video, we're going to have an introduction to organic chemistry. Before you watch the entire video, please try to complete this little discussion question here. I want you to think about what organic means to you. You don't have to look anything up. Simply write what your preconceptions are about what organic means. So now we're going to go and take a look at some basic definitions of organic chemistry along with organic compounds. Organic chemistry is, simply put, the study of organic compounds. To understand this definition, we need to understand what organic compounds are. Organic compounds are compounds that are made primarily of carbon-hydrogen bonds, and that can be compounds that occur naturally, so that are made in biological organisms, but it can also be compounds that are synthetic, that are made in the lab. So organic doesn't necessarily mean that it has to be something natural. What organic compound really means is that it consists primarily of carbon-hydrogen bonds. And we'll take a look at some example. Other compounds that are considered inorganic, so not organic compounds or inorganic compounds, they're compounds that do not have significant amount of carbon-hydrogen bonds. And the majority of the chemistry that you've seen so far in grade 9 to 11 and beginning of grade 12 has been based on inorganic compounds. So many ionic compounds are inorganic compounds because they don't have a significant amount of C and H. So let's go and take a look at the table below to see if we can classify compounds as being organic or inorganic. You can try these out yourself first, so maybe pause the video, make a guess whether it's organic or inorganic, and then provide a justification. Once you have your guess done and your justification, you can continue the video and take a look to see if you are on the right track. So we'll start with CaCO3. CaCO3, this is considered inorganic. Yes, there is carbon in there, but it does not have the CH. So there's no CH bonds. No CH bonds. So it's really missing that hydrogen component to be considered organic compound. CH4, well, that's a compound that's made up of C and H. That's all CH bonds. So it's considered organic. And then I just said the justification, but it's all CH bonds. CH3OH. So in CH3OH, you have CH bonds, right? So you have that plus bonds that aren't CH bonds, and that's okay. Organic compounds don't only have to be CH. They can be a bunch of CH plus a few other special groups that we'll see later on. So this is actually considered organic as well because it contains those CH bonds. So essentially, as long as you contain C and H, you're usually considered organic. Okay, let's take a look at H2O. H2O does have H, but there's no C. Since there's no C, this is considered inorganic. No C. CO2. CO2 is produced by living organisms. You breathe it out. But remember, that's not the definition of organic compound. The definition of organic compound is, contains CH bonds. So this has C, but there's no H. So CO2 is actually inorganic. No H. Okay, C6H12O6, some glucose. As you can see, this is a molecule that has C and H's in it, plus O's, and that's good too. That's fine. As long as you have a lot of C and H's, you can have other groups there. This is considered organic. So it does have those CH bonds. And then lastly, this one here does have a bunch of CH bonds and a Cl at the end. Cl is chlorine. Some organic compounds do have halogens connected to them. That's fine. We have a bunch of CH bonds here, so that's organic. CH bonds. Here, there's a similar exercise that you can try out. You can label these compounds or classify them as being organic or inorganic. So what you can do is you can pause the video, and then afterwards, when you think you're done, you can play the video again to check your work. So let's go through some of these. Ethane, this is a bunch of CH bonds, so organic. Water does not have the C in it, so inorganic. Propanal has a bunch of CH bonds plus this interesting little group here, but that's okay. A bunch of CH bonds, so we're looking at here. So that's organic. CO2 does have C, but there's no H's, so inorganic. SO2, sulfur dioxide, no C's, no H's. Nice and easy decision, inorganic. Propan-1-amine, whole bunch of C's and H's, an N over here. That's neat. But yeah, a whole bunch of C's and H's, so that makes this organic. Ammonia, it does have H's, but there's no C, so inorganic. This one here is a bit trickier. This does have C, but no H. And I'm just going to give a little aside here. This is actually made by taking CH4, which is organic, and essentially making it react with Cl2. And what you do is you basically pluck off, you remove each of the H's and replace them by Cl's to get CCl4. So when you first look at the compound, you'd classify it as inorganic because there's no H's there. But in reality, this is a derivative of organic compounds. Like, it was made from an organic compound. So technically, organic compounds are derivatives of organic compounds are still classified as organic. For now, though, if you would have placed wrote inorganic down, that would be acceptable. But later on, as we learn what the derivatives of organic compounds are, I would expect that you put organic for this as well. And if you want to be more specific, you can put derivative of organic compounds, derivative of organic compound, which is still considered an organic compound. So that there was a little introduction to what organic compounds are. In the next video, we're going to take a look at a little bit more about carbon and why is carbon such a big deal? Why is there such an emphasis on carbon when we talk about organic compounds specifically?